operating system from the batch of the system to the mobile OS. Today, we are going to dive into one of the most critical topic in a operating system, that is a process management and CPU scheduling. This is where the operating system is literally shows its power by managing how the program runs and make sure the system feels smooth and responsive. So let's get started. So the first question is, what is a process? Is first it is clear what is a process and what is a program. The program is just a sets of instruction like your recipe written in a cookbook. The process is the other hand is a program to in execution. It's likely the cooking the dish. So whenever you open the Chrome or play your music or run your Python code, each one of this is the process. So what does the OS do? OS do with this process? The operating system acts like a manager in a busy kitchen. So it creates the processes. It also schedules which process you get the CPU. It also working as a priority basis. It suspends and resumes your processes. It also terminates when it is you are the process is done. Without this management, your computer wouldn't be able to do the multitasking. So multitasking is a very important for the process point of view. The process there are total five types of process states. Every process goes through the different state during this timeline or a lifeline. So are the five ones. That is, first is a new, ready, running, waiting, or block, and terminated. So the new process is like a new process is being created. The ready ones is a process is waiting for the CPU. If the process is currently working running on the CPU, or it is a process is waiting for the some event like IO, that is input output, and terminated if the process is finished their execution. This OS gives the tracks of all the C process control unit, which stores the details like a process ID, your states, registers, memory information. So the next one is what difference between the process and threads. So process is a independent program with an open memory, and a thread is a smaller unit that that independent thread is a smaller unit of the process, sharing the memory with other threads in the same process. The examples are the Chrome for the your browser. Each tab can be work as a thread. Thread makes the program faster, and also, but it's also needed your careful management to avoid any conflicts. So the next part is a CPU scheduling. It is a height of the multitasking. Uh, the real your CPU is can only run one process at a time per core. If you are using a 4 core CPU or 8 core CPU, then you can consider say as a 4 process or the 8 process running on the same time at the same execution time. So but when you open the multiple apps, it you feels like you are running it simultaneously, because it's because the OS uses the scheduling algorithm. It also really quickly switch the process between two processes. The goal of the CPU scheduling is to maximize the CPU utilization. It also provides the fairness, so no other process stall. It also minimize your response time and your waiting time for that process or that task. So there are different types of CPU scheduling. First one we will see each one process scheduling type one by one. So the first one is your CPU first come first serve, like FIFO. Uh, this uses the processes are the saved as a order, uh, or as the order arrived like a queue at the store. It is non-preemptive, that is once the process starts, it will run till it is completion. The best example of this process is to if you have three jobs arrive, the one that comes first will run first, even if it is very long. So the pros of this scheduling is the simple and fair to arrive in order. The cons of this process is conveyed effect. It is very small, very slow. It may wait too long if your process is too big. The second one is the shortest job next, or shortest job first. This process is with the smallest execution time runs first. It is user preemptive, that is the shortest, remaining the first doing the first time first, or it is non-preemptive. It The pros of this process is it is optimal average waiting time. The cons of this process is it needs to prior the knowledge of the job length. It is not always possible for the CPU to prioritize your scheduling of the process. So the third one is the priority scheduling. Each process has their own priority number. If any task or the process have the highest priority, the CPU will run that task or process first, and the lowest priority will get the CPU time later. So, the cons of this process priority scheduling is it is good for critical tasking, and the cons are the it is low priority process may never run, or it uses the edging. It may take some more time, or if the in between the in between the processes, the highest priority task will come. It will solve that process or task first, uh, and if it maybe the lower priority task processes will never get any time slot from the CPU. The solution is it gradually increase the priority of the writing task, so that lowest priority processes will take some time, and it will run and execute perfectly. The last fourth one is a Robin Hood, Robin round robin. So each process gets the fixed times of slice like quantum, and if it is not finished, it will go back to the queue again. So, for example, if your quantum time is 10 milliseconds, the process A runs. Suppose there are three processes like A, B, and C. If the process runs for 10 milliseconds, the process B and it will run. A runs for 10 milliseconds, then process B will run, then the process C will run, and this queue will go on. The pros of this one is to it is a fair responsive. It is a great for time sharing system. The cons is it is performance dependent on the quantum size. So, and the fifth processing is multi-level queue scheduling. The processes are divided into the groups like system processes, interactive processes, and batch jobs. Each group has its own scheduling algorithm. The cons of this scheduling is to optimize the efficiency for different types of tasks. The cons are it is less flexible, hard to move the processes between the queues. The next one is a multi-level feedback queue, similar to the multi-level queue, but the process can be moved between the queue based on the their behavior. If the process uses too much CPU, it moves to the lower priority queue. So, and the pros are it is very adaptive and efficient, but it is very complex to implement. So, to understand this types of scheduling, that CPU scheduling, we can consider this as of one example. Suppose P1 needs 10 milliseconds, P2 needs 5 milliseconds, and P3 needs 2 milliseconds. I would like to know which one with above six CPU scheduling. Comment around which what is the efficiency, or which one is more efficient to process these three tasks to execute at what time. So please write your thoughts and your comments or your answers in the comment section. So we will move forward. Uh, so the next one is a key CPU scheduling metrics. When you are evaluating these algorithms, the OS looks at the CPU utilization. It keeps the CPUs are busy as possible. It uses the throughput, the number of process completed per unit time. It uses turnaround time, the total time from the processes arrived to completion. It also uses the waiting time to time spent on the ready queue. It also gives the response time, the time request to the first response. The different types of priorities, different matrices it uses. So real-time systems prioritize the response time. The batch system prioritize the throughput. The real life examples of this process management is Windows and Linux. It uses the high priority preemptive scheduling. It uses the Android that uses the Linux kernel for fair scheduling. The real-time operating system which uses the often user priority scheduling to meet the deadlines. So why does it matters? The understanding of this process management is a CPU scheduling is a critical because it explains why your app is sometimes freeze or it's lag. It also shows how the OS ensures fairlessly between the app for developers, it helps to design the efficient program that works well when with the OS. The conclusion of this video is the process is a program in execution. It managed by the OS. The process through go through the state like ready, running, waiting, and terminated. The OS uses the CPU scheduling algorithm to decide which process runs when. The algorithms like FC, FS, SJF, priority, round robin, and multi-level queue balance performance, uh, fairness, and efficiency. In the next time when you multitask on your laptop or your phones, remember it's OS schedule